real name of it though? The Pythagorean theorem?
Yes, it's the Pythagorean theorem. That's how you pronounce it. Yeah, so.
Yeah.
Hey, buddy, say that word.
Yeah, so everybody, Pythagorean. Pythagorean. That's what that is. The Pythagorean theorem. And we're going to learn about the Pythagorean theorem today. And in your notes, we'll start a page of notes here. So, geometry. Unit 2. We're going to only be talking about triangles in this second unit. But today, we're going to talk about a specific type of triangle. There are day 9 notes. This will be page 1. Okay. So before we go into that worksheet and talk about that new fancy word, Pythagorean theorem, we're going to talk about a couple of different types of triangles. And we're going to be drawing some pictures. So you may want a straight edge. And I'm going to kind of give this page a little subtitle, Classifying Triangles. CLASSIFY. And do any of you know what it means to classify something?
Classifying something?
Mm-hmm.
Like giving it a title or putting it in its own place?
Yes. You're kind of giving titles and creating different sections of triangles that have different types of things.
Yeah.
So like if we were to classify, I don't know, classify my pins, I could put them into groups based off of color. Okay, these are the reddish ones. These are the orangish ones. These are the bluish ones. Like that. We just classify them. Now, triangles, we classify not by color, but by angles and by sides. So, the first section under classifying triangles will be by angles. And I'll draw that little angle symbol here. And there are going to be 3 types of triangles that we can classify by angles. So I'm going to start with the first type, which is an acute triangle. So we have acute triangle. And I'm going to draw a line. We're going to have 3 little sections here. So next is going to be right, R-I-G-H-T, right triangle. Separate. And then finally, obtuse triangle. Highlight those. Now, an acute triangle, we'll put little descriptions under each section, is a triangle where all 3 angles are less than 90 degrees. So, all 3 angles less than 90 degrees. And remember, a 90-degree angle is the one that creates that like perfect square edge and we draw that little box inside of it. So, how I'm going to draw an acute triangle is I'll start with my ruler, kind of tilt it this way, and I'll draw a little line that's about 3 centimeters long. And from that first...
Centimeters?
Centimeters. Yeah, you can use inches if you want. If you're using inches, it's roughly 1.25 inches. Then I'll just do another line.
Another 3?
That first, yep, to make 3 sides. And it doesn't have to be perfect, but it does have to have all 3 angles less than 90 degrees. And we can see if I were to use the edge of my ruler right here, this is a 90-degree angle because it's that like perfect kind of square on the edge.
Yeah.
If I line it up with all of these, that's less than 90.
You ain't
That's
lying.
less than 90.
Yeah.
That one's less than 90. We're good. So we will mark these with our little angle marks to show that all 3 are acute angles. All 3 angles are less than 90. Now your right triangle is just going to have one angle that's exactly 90 degrees. One angle exactly 90 degrees. The other 2 don't matter. If you see one angle that's 90 degrees, it's automatically a right triangle. So I'll start with my ruler straight up and down, as close to straight up and down as I can get it. And I'll start with 3 centimeters. Then I'm going to follow my blue lines to make that bottom side. I'm going to try to start with that perfect 90-degree angle there. And then finally we'll connect the 2 lines to create our triangle. And to mark that this is a right triangle, we will put that little box on the 90-degree angle. So there's our right triangle. Our obtuse is going to be a triangle with one angle bigger than 90 degrees or greater than 90 degrees, right? Greater than 90 degrees. So 90 degrees is our reference. It's either bigger than 90, smaller than 90, or exactly 90. To draw this angle, or this triangle, I'm going to start with my first side. Instead of tilted in, I'm going to start with it tilted out, like this.
Proper.
There's my first side, starting at a little outward angle. My second side, I'm going to follow the blue line. So you should be starting with your angle that is bigger than 90 degrees, we see.
Then you connect it.
Perfect. Then you connect those 2 sides.
Diagonally,
yes.
It is greater than 90.
Here we go. So then we'll just mark that biggest angle, that obtuse angle.
That's cool.
So you can see if your triangle has even just one angle that's bigger than 90, it's automatically obtuse. We don't have to even worry about the other two angles.
Yeah.
If there is one angle that's 90, it's a right triangle. Now, the only way to have an acute triangle is when all three are acute. Because this one has two acute angles, the right triangle. But it doesn't matter because there's a 90-degree angle. The obtuse has two acute angles, but it doesn't matter because it also has one that's obtuse, that's bigger than 90.
Yeah.
So it has to have all three acute to be an acute triangle. All right. So that's by angles. Now we can also classify by side lengths. So I'm going to draw a line here. A little messy. And then I'm going to write a new title by sides or by side lengths. Side length triangles have some funky names. The first one is called an equilateral triangle. EQUILATERAL. Equilateral triangle. Next, I have isosceles. ISOSCELES. Give myself a ton of room on that. Something. And then we have, last but not least, scalene. SCALENE. Scalene triangle. So, an equilateral triangle is a triangle where all three sides are the same length. All three sides.
See you doing.
See ya. Same length. All the definitions first and then do pictures for these. Isosceles has just two sides the same length. One side will be different. So two sides are same length. Scalene is when all three sides are different lengths. So none of them are the same. Consider how we can draw pictures of these.
Whatever. Sounds
good. Sounds good. Okay, so an equilateral triangle It's hard to draw unless we really, really take our time with it. And get out like our protractor and get real specific. It's okay if your picture is not perfect. What we're gonna do is we're gonna try to draw a triangle where all three sides are the same. So I'm gonna start with 3 centimeters. And try to get it so that these other two sides can be about 3 centimeters, so I can kind of play with where that point needs to go. It's okay if it's not perfect. Yeah, see, mine's a little off, but no big deal. The way that we mark this is with tick marks. We use arcs for angles, how we did above, but below we're going to use tick marks. So because all three are the same, we put one tick mark on each side to show they're all the same. Now, isosceles is the easiest to draw. I like to start with 2 longer sides that are the same length coming down. So I'll start with one side, tilt it here, going to 4 centimeters. And then starting from that same top point, I'll do another 4 centimeter side. I'll just connect those 2 sides at the bottom to create my triangle. Now, something else I didn't have you mark on equilateral that I'll have us mark is that all 3 sides are the same length, but all the angles are also the same. Summary and angles. And it's going to be the same for isosceles. 2 sides are the same length, so 2 angles will be the same. And the 2 angles that are the same are the 2 bottom angles. So we have this one's the same, that one's the same. The 2 long sides are the same. And then I'll use a different color like red to show the ones that are different. This angle at the top is different. So 2 marks, and then 2 tick marks for the bottom side that's different. Plane, we need a triangle with all 3 sides that are different. That's also going to mean all 3 of the angles are different as well. Start with a line straight up and down. I'll make that one like 2.5 centimeters maybe. And then I'll do a line making like a right angle. That first one was 2.5. I'll make the second one 3.5 centimeters. And then we'll see that when we connect those 2 lines, the third side is more than that. It's about 4 1/4 centimeter. So they're all different. And we can mark that by giving them all different number of tick marks. So on that first side, I'll give it 1. The second side gets 2. The third side gets 3. They're all different. I'll also mark the opposite angles. So the side that got 1 tick mark, the angle opposite of it here gets 1 arc. The side that has 2 tick marks, the angle that's opposite of it at the top gets 2 arcs. And the diagonal side, that got 3 tick marks. The angle opposite here,
3.
gets 3 arcs, yes. Yeah.
Good. And it's on.
Yes, and angles, and angles, and angles. It's an and sign. And then once we've got this page of notes done, we're going to focus on the next page of our notes, specifically on right triangles. And we'll pull out that worksheet once we're ready. So I'll pause this and we'll unpause it in just a moment here. Okay, so we'll go to page 2. Day 9. Notes. Continue. To. Okay. So we are focusing specifically now on right triangles. Specifically those triangles with one 90-degree angle. And what we'll do is we'll start by drawing a big right triangle. And I am going to start with, let's see, my first side will be, I'm going to start a little lower so I can label it. First side will be 2 centimeters. And I'm going to label that side with 2 cm per centimeters. On the second side, we'll give it 3 centimeters. I'll label that 3 cm. We'll connect those 2 sides. And I'm not going to label that last side. Even though I could measure it, looks like it's about 3 and 3.7-ish, something like that. 3.6 or 7 centimeters. We're not going to label it yet. First, we're going to label different things. So I'll start with giving that 90-degree angle its box. And the 2 different sides that make up that 90-degree angle, I'll kind of highlight those with my red. And in a right triangle, we call these the legs. So this is a leg. This is a leg. And the opposite side, opposite of that 90 degrees, so I'll draw a little arrow and highlight that longest side. This is called the hypotenuse. So this is HYPOTENUSE, hypotenuse. And the hypotenuse is always the longest side, every single time. So whenever we have these two measures given to us, we have the leg measures. We don't have the hypotenuse measure. We're going to use Pythagorean theorem, which I'm about to give to you. So Pythagorean theorem. Pythagorean was the name of a man from many years ago who came up with this theorem. And it's a formula that helps us solve for missing side lengths. So Pythagorean, spelled Pythagorean, Pythagorean theorem, Theorem. And that theorem is, we call the legs A and B. So I'll put an A next to this leg, a B next to that leg. You can say A squared plus B squared
Equals C squared.
Yes, equals C squared if the hypotenuse is C. Good. So just kind of label this A and B. Doesn't matter which one you make A and B, it just has to be the two shorter sides. Or the legs. And C is the hypotenuse, or the longest side. Circle that. This is an important formula. Pythagorean theorem. So what we're going to do here is we're going to solve for that missing side using the Pythagorean theorem. So I'm going to write here solve for the missing side. We're using this picture. We would take that A squared plus B squared equals C squared, and we'll plug in what we already know. We know that A, we'll call that 2 centimeters. So we'll put 2 squared plus, our other leg is 3, so 3 squared equals, we don't know the hypotenuse, we don't know C, so we leave it as C squared. So we plugged in our A and B, and now we're just going to solve it out. So first step, we're going to take 2 squared, which is 2 times 2, which is 4, plus 3 squared. 3 times 3 is 9. Good. Bring down equals C squared. Now what's 4 plus 9? 13. So 13 equals C squared.
The C can't be squared though.
C can't be squared though, you're right. So what we have to do is solve for C. And we do that by using the square root. So if you don't have a calculator yet, grab one. I'm going to show you how to do that on there. Oh, you got one. Okay. So to find the square root on your calculator, you will use the second button, the blue button, and then x squared right above it. You can see the square root symbol. So you'll click x squared, and you should have something like this pop up that looks like the square root. And then we're typing 13. Enter. We get 3.6. So what we just did here is when we find the square root of something, we're asking what can I multiply by itself to get that number or to get that value. So c squared is the same thing as c times c. So the square root of c squared is c. So c equals, and we just found out the square root of 13 is 3.6.
So you basically got to square both of them, square root both of them.
Yes. That gets rid of our squared on the c, and it brings us our answer. And that would be it. And we know that that's right because my, let's see, when I measured my side length, you can see it's just a little over 3.5 centimeters. It's about 3.6 right there. So it's correct. Okay. So that being said, this one was a little easier because C was what we were solving for. But now let's say we have something like this. Let's use number 1 on this worksheet. Number 1. I'm going to write up here. This is our day 9 worksheet. So first, this triangle is flipped around. It's not like the one in our notes. We need to figure out what side lengths are our legs, the shorter sides, and then which one is the hypotenuse. Now the hypotenuse is always right across from the 90-degree angle. So if I find my 90-degree angle first,
8.4.
yeah, 8.4. So that's our hypotenuse, which means that will be our C. That means 6 and X are A and B. And it doesn't matter which one you put for which. You could make X your A and 6 your B. 6 can be A, X can be B. They're interchangeable. So now if we're using A squared plus B squared equals C squared, and I plug these values in, what will I write?
X squared plus X squared equals 8.4 squared.
Perfect. 6 squared plus X squared equals 8.4 squared. So going through the same process, we need to square everything. So
You square root. Are you not gonna be able to square root X?
we can't yet. Eventually we
Till
will.
after.
Yeah, till
Yeah,
after.
36.
So we'll start with 6 squared. What does that give me?
32.
36. Can't do x squared yet, so we'll just bring it down. Plus x squared equals, now what's 8.4 squared?
2.9.
2.9.
I say 2.89.
Okay. I think you might have done square root. 8.4. We don't have to hit second this time, just the x squared button.
I'll put 8.4 in the X squared.
Mm-hmm.
Okay.
What you,
70.56.
perfect. 70.56. Okay. Now, before we can find x by itself, we need to get it to where it's the only thing on this side of the equal sign. So how can I do that?
Subtract 32.
Good. Subtract 36 from both sides. Bring down x squared, bring down equals. 36 and get
34.56.
perfect 34.56. Okay, so now if I have x squared but I want x, square root.
Now I'll do the 34 point.
Yes, so we'll start with the second button, x squared, to give us the square root, and then 34.56.
Let's say 58.7, so it'd be 5.9.
Yeah, you could write 5.9, you could write 5.88 if you want to round up, you could write 5.87. I won't be super picky on how you write your answer, as long as you don't just round it up to like 6. I want 1 or 2 decimal places, so I'm gonna
So
put,
these is gonna give us decimals.
yes, a lot of them will, So I'm gonna round that up and do 88. So x equals 5.88. And our units are in miles, MI. So we'll put the units in our answer. Yeah, that's number 1. And a good way to make sure that your answer makes sense is if I'm finding the length of a leg, it has to be shorter than the hypotenuse. So if I got like 9 or something, I would know I did something wrong. But our answer makes sense. 5.88 and 6. 8.4 is longer than both, so that makes sense.
So anytime the longer ones crossing on the 90-degree angle, it's automatically the hypotenuse.
Automatically, yes. The hypotenuse is always the longest side and it's always across from 90. So what would my hypotenuse be on number 2?
15.6.
Perfect, 15.6. That's our hypotenuse. So that's C, always. A and D don't matter as much, as long as they're the 2 shorter sides. So I'll make X my A. 13.6 will be B. And now that I've got it all labeled, what equation could we write?
X squared plus 13.6 squared equals 15.6 squared.
Perfect. Perfect. Same process, write the equation, square anything that needs to be squared.
So 184.96.
Perfect. 184.96 equals, I'll put down x squared plus.
It's 243.36.
Perfect. 243.36. Okay. There. What should we do?
Subtract 184 from both sides.
Good. Minus 1. 6.
58.4.
Good. 58.4. How do I find x?
Square root of
Good. Square root
both sides.
Yes. We get, let's see.
7.6.
Perfect. 7.6. I'm gonna write 7.64. 7.6 is fine.
7.6 centimeters.
Good. 7.6 centimeters. Perfect.
So we would, like, if we do this on a test and we didn't put the centimeters, then we'll get it wrong.
If I'm asking you for units, it would be like half a point off or something. I'll definitely let you know whenever we take our practice quiz. I'll make it the same, and you'll know if I want units or not. I may not. I can't remember. But if you have units, use units. Let's see. Let's do one more together. We'll do number 3, and then I'll give you some time to try them on your own.
6.6 squared plus x squared equals 15 squared.
Good. 6.6 squared plus x squared equals 15 squared.
See,
Good.
225.
Or equals 225.
Right, 43 for both sides.
Good.
It's 181.44.
Perfect. That's what I got. Okay, last step.
Square root both sides.
Yeah. Yes.
13.5.
Yes, 13.5. We got 13. Good centimeters. We got 13.4699. So if you were to do 2 decimal places and round up, we would do 0.47. 13.5 is perfectly fine. I would absolutely take that. Okay, so that was number 1, 2, and 3. I would like for you to try to do number 4, 5, 6, and 7 on your own. I'll set a timer. Now, if you get further than that, feel free to keep going. But I'm going to give you 15 minutes. Try as many as you can. I'm going to pause this. Okay, so our timer just went off. 12 is the farthest we got. And I am going to go through each of these problems and give you the correct X value. Now, as I go through, if any of the answers don't match what you got, let me know. We can take a look at it. So for number 4, you should have gotten X equals 12.5 yards.
Yeah.
You got that one? Okay, good. All right, number 5, you should get X equals 9.9 yards.
Yeah, I got that.
Oh, or not yards, miles. Moving on, number 6, you should get X equals 2.8 centimeters. 7, you should get X equals 13.2 kilometers. Number 8, you should get exactly 7 inches.
I got 8.
You got 8 inches.
I got 8. That's how I did it wrong.
Okay, well, let's look at it. Answer key could be wrong. What equation did you write?
I put X squared plus 12.7 squared equals 14.5 squared.
Okay, so x squared plus 12.7 squared equals 14.5 squared. And what did you do from there?
Squared 12.7
Okay.
and 161.29. Yeah,
Perfect.
squared 14.5. I got 210.2. Hold on, that's where I messed up.
What'd you get?
I must have put something. When I just did it now, it says 210.
Yep, that's right,
I
210.
did. I don't know where I got 240 from.
Huh, I don't know, 240. Interesting. Wonder what you typed.
I can go back.
Yeah, if you arrow up, you should be able to see your history. See what you typed to get that 240 something.
It's crazy because I put the set. I put.
Right, you had it set up right.
Hold on, this is different. Oh, I know how I got it.
What'd you do?
I put 15.5.
That does it. That'll do it. Okay, well now we've got the correct 210.25, and I'm sure you know what to do from here. Subtract 161.29 on both sides. Should leave us with x squared equals 48.96. Square root of both sides gets closed.
Yeah.
Yeah, 6.997 and so on. So if we were gonna round,
It'd be
it would be 7 inches, yeah. Good. Okay, number 9, you should get 16.4.
Yeah, I got that.
Good, x equals 16.4 yards.
On number 12, I put 14.77, but it could be 15 though.
14.77, you're right, my answer key says 14.8. So that's good. I wouldn't round it up to 15 though.
But you could say if it's over the hypotenuse, then it's wrong.
If it's over the hypotenuse, then it's wrong.
If it's higher than the hypotenuse.
Yes, if you were to get a number bigger than 15.4, you would know you did something wrong. Yeah. Number 10, our answer should be 12.3 feet.
Yeah, I got that.
Good. 11 should be 9.4 inches.
Yeah, I got that.
And 12, again, was x equals 14.8 yards. So, there we go. All right. I'm going to go through and give you the rest in case you want to have an answer key and practice this later. But for that number 13, you should get 13.7 centimeters. 14, you'll get 6.4 miles. 15, you'll get 3.4 centimeters. Flip to the back, last 5, number 16, you will get 10.9 yards. 17, you'll get 13.1 feet. 18, you'll get 5.4 kilometers. 19, you'll get 8 centimeters. And 20, you'll get 12.7 feet. Okay. There we go. Good stuff. So that's pretty much as complicated as it gets with the Pythagorean theorem. So we'll put these to the side. Here, answer guide. And we can use this for when we have 2 side lengths given to us. That's the only time we can do it. But now we'll go back to our notes, and I'll try to get the next little bit of notes here before the bell rings. So we can use the Pythagorean theorem when we have 2 sides given to us. So I'm gonna write when we know 2 sides or 2 side lengths. That's when we can use the Pythagorean theorem. I'm going to start our 3rd page of notes next, but then I continue. And now we're going to talk about some special cases. Special right triangles is what we call these. So I'll just title this special right triangles. There's 2 types of special right triangles. So I'm going to start by splitting my paper in half. I'm going to draw a big long line somewhat down the middle, top to bottom here. We have 2 different types here. The first type is called a 30, 60, 90 triangle. So 30 60 90. And then the other kind is a 45, 45, 90. And these numbers are referring to the angles inside of these special right triangles. There's a 90 on both of them. The 30 and the 60 talk about the other 2 angles. 45 and 45 talk about the other 2 angles as well. So I'm going to grab my ruler and we're going to draw a picture here for my 30, 60, 90. Start with a line going straight up and down. And I'm going to make my first line 5 centimeters. And make this second line about 3 centimeters, maybe a little less. And then my third side will be close to 6 centimeters, more like 5.5. And 30, 60, 90 triangle is always going to have this more elongated look, where you've got a real tiny angle up here at the top. Got your 90 in the corner. And your 60-degree angle right over here at the bottom. Now this could be flipped around. This could be rotated. It depends on how your triangle is drawn, but it'll always have these same angle measures. So if we want, we can label 30 degrees there, 60 degrees here. And we know that that box is 90. And we're going to label the sides with some X values. So right across from the 30-degree angle, that's our smallest angle. So our smallest side is across from that. We call this X. Our biggest angle is 90. Across from the 90, the biggest side is 2x. The hypotenuse is 2x. And our middle side has kind of a funky x value. The one that goes straight up and down here is x square root of 3. And that's a kind of a mouthful. So instead of x square root of 3, we say x radical 3. X radical 3. And that's just another way to say square root rad. And I'm going to label the points that make up the triangle. The one at the 90-degree angle, that point is going to be A. The point at the 30-degree angle is B. And the point at the 60-degree angle is C. Once you got that, now we're going to draw our 45, 45, 90 angle. So for this one, we have two angles that are the same. We're also going to have two sides that are the same. So my first side going straight up and down, make that one 5 centimeters. And then to create the 90-degree angle, we'll make another side going along the blue lines of our paper. That's also 5 centimeters. And then we'll just connect those two lines, two legs, and draw the hypotenuse. And this is also the longest side. Okay. So we'll start by labeling our angles. We know this is our 90-degree angle. And the other two are equal. They're both 45 degrees. Now, since these are both 45-degree angles, they're equal to each other. The opposite sides of those 45-degree angles will also be equal. So our legs, the one at the bottom across from this 45-degree angle, we call X. And the other leg across from the other 45-degree angle will also be X. They're the same length every single time. And then finally, your hypotenuse, your longest side, will be X times radical 2. Instead of 3, it's 2 this time. And we'll give this one points as well. And we'll finish this before I give you a break. The point on the 90-degree angle is D. We'll call E the 45 at the top. And then F, 45 degree at the bottom. All right, so since the bell just went off, we will take a little break. And then we'll come back. Okay. All right, so let's look at the 30, 60, 90 triangle first. And I'm going to give you an example of how one of these problems might look. So for the first example here, you're going to have a list of things that are given to you and then a list of what you need to find. So it will say something like given, and then it will list off the different side lengths. So I'll say AB, or AB equals, and I'll have you find the rest. So given AB is 43.3, go with inches. Then you'll need to find AC and BC. So C, C. So this is how a problem for the special right triangles will look. We know that AB is 43.3. So we're missing two other sides. And the first thing that we want to do is figure out what is the x value of the side length that we're given. So 43.3 is the length from A to B. A to B. The x value from A to B is x radical 3. So I'm going to come down here and I'm going to write AB equals x radical 3.
No, we would square root, like, we would put, we gotta do something with that 43 one.
We do. We need to find x. Because once I know what x is by itself, I can say, well, now I know what AC is because that's x. I can plug that in, take it times 2, and I'll know what BC is. So step 1 is to solve for x. I know that AB is x radical 3. I also know that AB is 43.3. So we can start by saying x radical 3 equals 43.3. And what we do here is, first of all, radical 3 is just a number. And when we have a number next to x, it means that number times x. So we're going to type this into our calculator. To get rid of radical 3, since it's x times radical 3, we will divide by radical 3 on both sides. So I'm dividing by radical 3 here, and I'm dividing by radical 3 on the other side. And here's how we type that in. Charge my calculator. Okay, so I'll type 43.3 divided by, we use the second button and get our square root of 3. So it's 43.3 divided by the square root of 3. Enter. And I'm going to get 24.999. That's so close to 25. We'll just round it up to 25. So on this side, my radical 3 is canceled out, and I get x by itself. And we just found that 43.3 divided by radical 3 is about 25.
So we're using AP to figure out what x is and then
Yes.
plug x into the other two.
That's exactly right. So if x is 25, what else do I know?
A and C is 25.
Yes, A to C is 25 because that's x.
We won't have to do nothing extra for that, it's just X by itself.
It's just x by itself, that's it. We'll just write inches, 25 inches. Now that I know what x is, and I know what AC is, can I use that to find BC?
Yeah, 2 times 25.
Perfect. 2 times 25, which is
Yeah.
good. So we just did 2 times 25. It's 15. Just plug it in for x. Good. Okay. So let's see. Another one like that. I think we have enough room. This time, let's say we are given BC. And we're going to say that BC is 42 inches. And we need to find AB and AC. I know that BC is 42. We'll look back at our picture and see what X value does BC have.
X.
2x. Good. So if BC is 2x and BC is also 42, I can say, write this here, BC is 2x. It's also 42. So we can write 2x equals 42. Does that make sense how we got this?
Yeah.
Okay, perfect.
It's
So-
just going off the whatever side, like
Yes.
we get AC, then we're given AC, then we just look for AB and BC.
Yep, that's
We
right.
have to use X.
Yes, so we need to find x first. So, covering that up, how do I solve for x?
To the bottom line.
Divide by 2 on both sides. And we get x equals 21. Good. So, if x is 21, what else is 21?
2X. Or what else is X is 20. So that means. So we still going off the 2X angle.
We're going off of, we know that 2x BC, that is 42, because that was given. I just solved for x, so which side is,
21.
yeah, x is 21 and this side
AC
labeled,
is 21.
perfect, AC is also 21, because that's x. So I have AC, 21 inches. Now, I know that x is 21. What is AB labeled as on your picture?
The X square root of 2.
Yes, x squared of 3. So, just like on the first example, when I wanted to find 2x, I just plugged in 25 for x. If x is 21, we can just plug in the x to the x radical 3. And you don't have to do anything fancy except for type it in on your calculator. We will literally just type 21 square root of 3 and hit enter.
36. 36.37.
Perfect, 36.37. Inches. Good. Okay, so if we were given x right off the bat, we would plug it into the other two to find the other values. But since on these two examples we didn't know x, we solved for x first. So that's the harder version, the 30, 60, 90, because all three are different. 45, 45, 90 is a little easier because two sides are the same. You have less work to do. So let me give you some examples for this one. This time I'll tell you that what is given is that DE is 12 centimeters. And you need to find DF and EF. So if DE is 12 centimeters, what X value is DE labeled as? You're okay. I know that DE is 12. What else is DE labeled with? X. So right away, I know that 12 centimeters is X. What else do I know?
D and F the same.
D and F is the same. DF is also X. So it's also 12 centimeters. And if we know that X is 12,
12 square root of 2.
perfect. We'll just plug it in and do 12 square root of 2. And that'll give us EF.
16.97.
Perfect. 16.97. EF. Good. One more with the 45, 45, 90. Let's say this time I tell you, giving you that EF is 36 inches. You need to find DE and DF.
So 6 inches equal X square root of 2.
Yes. EF is X square root of 2, and it's also 36. So we'll set that equation up first. X equal 2 equals 36. So from there, remember, this just means X times the square root of 2. How do I get rid of that square root of 2? Divide. Both sides. So,
25.4.
perfect. 25 point, you could go with 0.4, 0.5, 0.46, it can be rounded. I'm gonna do 0.46, just to give myself a few more decimals. Okay, and now that I know what X is, what's the rest here, DE and DF?
X is 25.4
Mm-hmm.
for both.
For both, good. DE is X, DF is X, so DE is 25. 25.46 inches. DF is also 25.46 inches. Good. Good. Okay, perfect. Good. All right, now, so that you can practice that a little bit, I have these little worksheets here where on one side I have 45, 45, 90 triangles with the same DEF labeled. And then I went ahead and labeled your X values for the first one. And each problem has different given lengths. So you can practice a few of those. And then the back side has our 30, 60, 90, where we have ABC labeled the same as our notes. I went ahead and gave you X values for the first one, and then different given values on each. Now, it doesn't say given and find, but the given is the one that I gave you. So that should be pretty self-explanatory. I'm going to give you one of these, and I'm going to give you some time to try them on your own. And I'll set a little timer. Okay, so I am going to start on the 30, 60, 90 side, where you were given that BC is 22.3. For the rest of them, I want you to check and see how you did. So for AB, you should have gotten 19.31. And for AC, 11.15.
Yeah, I put the 1.5 and a 3.1. I put 11.3 in them. I put 11. I just rounded it.
That's fine. As long as it's rounded and it's close enough. As long as you didn't say like 20 and 11. That, yeah, 19.3 is perfect. 11.1 or 11.2 would be good. The next one, AD, you should get 24.6. DC, 28.4.
I got 25 on what I did get something. Unless I just wrote it down.
How did you find that 25? Was that for AB or BC?
AB.
AB. Okay. So I have that 14.2 is my X. So I plugged it in 14.2 radical 3. Type that in. This is what my calculator gave me. You get that? Okay, good. Maybe you round it up.
I probably did.
Maybe. It's okay. Yeah, we'll try to keep them as decimals just so they're more accurate. Did you get 28.4 for BC?
Yeah, I got 28.
Okay, perfect. Who knows? Maybe. I don't know. I don't know what you did.
I probably just going too fast. I probably just typed in 25.
That's all right. Moving down to, I really should have numbered these. Below the first one, this will be the third one. We were given AD is 47.3. AC, you should have gotten 27.31. BC, 54.62.
Yeah.
Good. Next one. AC is 7.16. BC is 14.32.
I got 14. Oh, I got 14.4.
14.4. What was your X? Did you have 7.2?
Yeah.
That's why. 7.2 times 2 would be 14.4.
That's because I keep rounding it.
Yep. That's okay. So that's usually why I like to keep 2 decimal places, because it will give you a little bit more of an accurate answer. But if I had seen like on your work, I wouldn't count that wrong. That would be right. Next one. Got AB is 30.66. And AC 17.7.
Yeah.
Perfect. Okay, last one on this page. AB 12.99, BC 15. Perfect. All right. 245, 45, 90s. Got DF is 107.5 and EF is 152.03.
Yeah.
Perfect.
Oh,
Oh, you're fine. You're fine. You can take it.
okay.
Okay, so
I got that too.
good, good. Okay, next one. I got 18.10 for both DE and DF. Good.
That was easy.
This one?
Like that, the E, the D, that was.
Right, right. It's a lot easier when you only have to find one different value.
I really started messing up because I had just did the other page, and then when I got to the
Second
EF, I was
guessing.
putting X. I was doing X squared 3, and then I had to switch
Uh-oh.
it back to 2.
Oh, sounds like you figured it out though, so that's good. DF 200, EF 282.84. Good. Last two, 24.75 for both.
Which one is it?
The bottom left where we were given EF is 35.
Ooh, I got
This one here. What did you get?
I got 49.5 or something. Yeah. I did the X square rooted 2 equal 35, and that's what you're supposed to do.
Yes.
And
And
then I
then
divided.
I wonder, sometimes I see people accidentally multiply by radical
I
too.
probably did that too.
Yeah, try typing it in again. I want to make sure you get the right one.
So, yeah, it said 24.7.
Perfect. Perfect.
No, I probably put 3. I probably put 3 right there.
Okay. That might do it too. Last one. DF 72.8. EF 102.95. Perfect. Okay. So that is it for content today. And last of all, here is the exit ticket for day 9. 2 different triangles. First one, we'll use Pythagorean theorem. Second one, special right triangle, 45, 45, 90. That is it.